Hello students, hope you all enjoyed your Diwali. Children, I'm making this video because since almost 3-4 days I'm getting 2-3 queries. In fact 3 questions which many of you have posted me that you want me to solve them and you wanted a recorded session on these 3 questions. So I'm taking it in our channel and I'm including it under the section KUCH KHAAS hai. Let us see what are the questions. If the heat of formation of sulfur dioxide and sulfur trioxide are M and N respectively, then the heat of combustion of SO2 is. So students, मुझे यहाँ heat of combustion sulfur dioxide का निकालना है. तो सबसे पहला काम जो हम करेंगे वो ये कि हम एक डिजायर्ड इक्वेशन लिखेंगे, यानी कि हम हमारा एम लिखेंगे that we want to find heat of combustion for which equation, and the question is telling for the combustion of sulfur dioxide. So I write the desired equation where I take sulfur dioxide gas and I carry out its combustion with oxygen gas. We all know sulfur dioxide on combustion will give sulfur trioxide. Here I am using 1 atom of oxygen or half molecule of O2. This is my desired equation. Now what I have to check over here is, I have been provided with heat of formation of SO2 and the heat of formation of SO3. So I can solve it. I'll tell you its solution in 2 ways. I'm writing given. Of course, I have to frame the equation for that because they've not given me the equation. Sulfur dioxide formation. So SO2 is here. And I can make it from the element sulfur and oxygen. And sulfur and oxygen combine to give me SO2. And delta H is given as M. Similarly, another equation, S plus O2 gas, but here I want to make SO3 gaseous. So 3, so here I am taking 3 by 2, so 3 to 6 oxygen, 6 by 2 is again 3 oxygen. And students, delta H for this reaction is N. Now I look at the desired equation, and when what I find when I look at the desired equation is, the first thing I want is sulfur dioxide, which I see in this equation, say A, and this is say B. So I see it in equation A. It is on the right side, but students, in equation A, sulfur dioxide is on the right side, but in the desired equation, I want it on the left side. So that I have to revert it. And as far as the numbers are concerned, I have 1 SO2 given, and in desired also I want 1. So I don't have to multiply or divide this enthalpy. So I can say revert A. So I want to revert A. So when I revert A, it becomes M evolved. Next thing I want is half O2, but oxygen is in both A and B. And I have told you many times, whatever you see in both the equations, just neglect it. Whatever you see in more than one equation, just neglect it. So I am neglecting O2. And I move ahead, and in the desired equation, I come to know that I want a molecule of sulfur trioxide, which I see see in the given equation B, it is on the right. I want on the right. It is 1. I want 1. So as it is. So no need to multiply, divide, revert or do anything to equation B or its value. So it becomes m plus n. That is, the answer becomes n minus m. The answer becomes n minus m. Okay? I hope this is clear to you. You can look at the video for around 10 seconds. Just see what is being done. You can also pause the video and you can record. You just pause it and you can record. So I hope this is clear to everyone, what we have done. This is our delta H for the final equation. So anyone is having doubts, since this is a live session, you can also ask me doubts. Okay, so I think nobody is having the doubt. So we can proceed further. Shall I give, okay, somebody is asking for an alternative way. Okay, I tell you an alternate method here only. Alternate method. Here only I am giving you an alternate method. See, you want delta H for this equation and formation is given. Formation is given. So delta H for the desired equation when formation is given is HP minus HR. That is enthalpy of product minus reactant, summation product, summation reactant. So children, product is SO3 and SO3 value is N. So it becomes N minus M. So anyway, you can solve it. This is the answer. I hope it is clear. This is a much easier method, of course, but to understand this method finally, you should understand this part also. You should know all the methods. Okay, now this next question. Question number 2 is saying, given that the data for neutralization of a weak acid HA and a strong acid is given, and these are the values given. The weak acid HA combines with hydroxyl ion to give A minus and water, where the change in enthalpy is 41.80 kilojoule evolved. And similarly, when a proton reacts with hydroxyl ions, we get a molecule of water, and delta H is 55.90 kilojoule evolved. You know, students, when a strong acid and a strong base react, we get 57.32 kilojoule evolved, which is the enthalpy of neutralization of a strong acid and strong base. From this value 55.9, it's very clear this is a weak acid. Now let us see what I have to find. Oh, I have to find the enthalpy of dissociation of the weak acid. So students, I am writing the desired equation. I can hear some people are answering the desired equation. Oh wow, Mrunali has written in the chat box that it is HA giving, since it's weak, I am giving reversible arrow. Mrunali have not given reversible arrow, but the only thing is you have to give reversible arrow in your equation. You have given single-headed forward arrow, you have to just give reversible arrow, that's all, nothing else. Since it's weak, it will be feeble dissociation. Now I want to find the delta H of this desired equation. So what to do? Let's see what to do, children. Same thing. What is the first thing I want? HA, where it is in the first equation. Say I label it equation A and I label this equation B. So I want it in the first equation. HA is on the left. I want it on the left. It is 1. I want 1. So delta H desired is equation A as it is. Let us see what's the next thing I want. I want H plus. H plus is in equation 2. And it's given 1. I want also 1. But look carefully. It's given on the left, but I want on the right, meaning I have to revert equation B. So I write here revert equation B. And when I revert it, let us see what happens. Delta H desired is equal to first value as it is 41.80 KJ as it is plus revert B. So with a positive sign 55.90 kilojoule. Whenever you revert the equation, children, you revert the sign also. So I think it is clear. What's the answer? Delta H desired will be, just add the 2, that is 55.90 minus 41.80, which is 14.10 kJ, kilojoule. So that was question number 2, which is clear to you. I hope the question is clear to you. Let us see what's next. One more I'm taking. I've taken 3 queries which you gave me. Oh, this looks difficult, but it's very simple. Ammonia gas reacts with 3-chlorine to give NCl3 and HCl, whereas nitrogen-hydrogen react to give ammonia and hydrogen-chlorine react to give HCl. Okay, this all is given. So this all is given to us. So that's the data. Even the enthalpy changes are given. They want us to find the formation of NCl3. Okay. So the very first thing I do is I write the desired equation. Let's see what's the desired equation. I want to find the enthalpy of formation of NCl3. So I am making NCl3, which I can get from nitrogen and chlorine. These are the elements. I write their atomicity to each. But nitrogen, I want only 1. But here there are 2 atoms of nitrogen. So I multiply it with half. Half of N2 is half of 2N. So half N2 is nothing but half into 2 times N. That becomes 1 time N. Similarly, here I'll do 3 by 2, which is again Cl3. Okay. Now I want to find this desired enthalpy from above 3 equations. Okay. I'll also write the calculation part. Okay. How do we calculate? I'm writing that also. You'll enjoy. Okay. What is the first thing I want? N2, which is in equation 2. Okay, this one. Now, N2 is in equation 2, but in equation 2, it is on the left, and I want also on the left. It is 1, but I want only half. So the very first thing I will do is, I will say, multiply equation 2 by half, first thing, because I want half N2. So I multiply it. Half N2 gas plus 3 by 2 H2 gas gives NH3 gas. And children, I multiply the value also. Okay. What is the next thing I want? Chlorine. Chlorine is in how many equations? It is in 2 equations, 1 and 3. Whatever is in more than 1 equation, just neglect it. Okay. What is the next thing I want? NH3. No, I want NCl3. This NCl3. It is in which equation? First. Which side? Right. How many I want? One. I want. One I have. I want on the right. I have on the right. Okay. So equation 2. No, sorry. Equation 1. जैसा है वैसा है. As it is. So I'm writing NH3 gaseous plus 3 chlorine gaseous is giving me NCl3 gaseous plus 3HCl gaseous. As it is, so delta H1 evolve as it is. So you have used equation 1, that is this one, and you have used equation 2, but you have not used equation 3. Okay, so you have to think, we can't leave equation 3, let us see how we can use it. Okay. Now, in this equation, as we see, this HCl is extra. And this NH3 is extra. No, NH3 is not extra. NH3 will get cancelled. No problem. Here only it gets cancelled. N2 इधर है, H2 भी इधर है. नहीं, N2 है, Cl2 है और NCl3 है. So H2, ये H2 और ये HCl, ये extra है. So we will use equation 3, that is this one, to nullify it. Okay, what I want to nullify? I want to nullify 3HCl on the right using equation 3 because that is only having HCl, but it also has HCl, that is 2HCl on the right. But to cancel it, I want it on the left, so I say revert equation 3. But अगर मैंने इसे revert कर दिया तो ये 2HCl आएगा, लेकिन मुझे कट करना है 3HCl, so I want this 2HCl, this to be 3. So what I do? And multiply by 3 by 2. Revert and multiply by 3 by 2. So I get 3 by 2 into 2HCl gaseous gives 3 by 2 Cl2 gaseous plus 3 by 2 H2 gaseous, and here also I revert, so minus delta H3 and it is 3 by 2, so into 3 by 2. Now let me see what I want. Am I getting it? I did so many things, but am I getting what I want? Let me just check it. Okay, so I am checking it. Ready? Okay. हाफ N2 किधर कट हो रहा है? नहीं. अगर आपको कुछ भी काटना है तो वो राइट साइड में होना चाहिए, ठीक है? अब हाफ N2 लेफ्ट साइड में, लेकिन राइट साइड में कोई भी N2 नहीं, नो N2. ना. So ये हाफ N2 ये लिख लिया मैंने. Now 3 by 2 H2 इधर भी है और 3 by 2 H2 राइट में भी है, लेफ्ट में भी है, तो ये कट हो गया. NH3 ऑलरेडी कट हो गया है. 3Cl2 लेफ्ट में और 3 by 2 Cl2 राइट में, यानी हो गया 3Cl2 minus 3 by 2 Cl2, तो 2 3 6 6 minus 3 is 3, तो ये हो गया प्लस हो गया ना भाई 2 3 6 minus 3 by 2, so 3 by 2 Cl2 गैस. ये भी सॉर्ट आउट हो गया, ये भी हो गया. इसको सर्कल कर लेते हैं, नहीं तो किसी को डबल कैलकुलेशन ना कर दे, बस इसलिए. अब ये 3 by 2 2HCl है और 3HCl है, ये कैंसिल हो गया, दोनों इक्वल है. खाली ये बच गया NCl3 जो कि राइट में है, तो इसे लिख देते हैं. So hence solved. So what is your final enthalpy? I'll just erase this. I'm just erasing this, students, and I will write the final answer here only. So the final answer is here. Delta H desired is, ये सबको ऐड करना है. किसको? इसको और इसको, इतनों को ऐड करना है. कर देते हैं. Final answer is delta H1 negative plus delta H2 by 2. यहाँ से ये हटा देते हैं. रुको थोड़ा सा. I don't want you to be confused. Okay. I am just rewriting it, students, because I don't want even a smallest element of confusion. I want you to be super. So delta H desired is delta H1 छोटा छोटा लिख रही हूँ जिससे कि फिट हो जाए, and delta H2 by 2 and 3 by 2 delta H3. So this is the answer. The question was little lengthy, but it was not at all difficult. So, my dear students, thank you so much for attending and asking me doubts continuously. Once again, thank you. Keep watching. Love and blessings to all of you. Take very good care of yourself. Enjoy yourself.